Hello and welcome to my channel. For this video, I wanted to do something a little bit different. This is going to be a lesson in object-oriented programming, and we're going to use Unreal Engine for some examples. Here I am in Jim's coffee shop, and there's a customer at the counter. The customer wants to order a coffee, and this is a perfect scenario to go through the basics of object-oriented programming. So what is object-oriented programming? Well, in object-oriented programming, each object in your program is defined by its own class, and each class has its own methods and attributes. A method represents an action or a verb, and in programming, these are often defined by functions. An attribute represents a characteristic of your class, or a noun. And in programming, these are often defined by variables. And there's four basic principles of object-oriented programming: encapsulation, abstraction, inheritance, and polymorphism. So what's encapsulation? Well, encapsulation basically says that all private variables and functions cannot be accessed by other classes. This prevents unintended bugs, and it can also go towards preventing malicious activities. Essentially, each class doesn't share information that other classes aren't privy to. And here's an example of encapsulation. The customer goes up to the counter and they want to buy a coffee. But when they're paying for the coffee, the shop doesn't need to know how much money the customer has in their wallet or in their bank account. The customer is responsible for determining whether they can pay for the coffee. So the cashier would tell the customer how much the coffee costs or how much the order costs, and then the customer determines whether they have enough to pay for it, and then pays the total. Let's say our cashier has a function called finish order. It would only return the cost of the order, and using an interface or a dispatcher or something, the cashier would tell the customer class that they need to pay for the order, and then the customer would call their pay for order function, taking the input of the cost of the order, and maybe they check their wallet first. So they may say, if I have enough money in my wallet, I'll just use cash. But if I don't, I'll use a credit card. In this example though, the cashier never sees inside the customer's wallet. The customer is responsible for knowing how they want to pay. Abstraction means that the functions and variables only expose useful information. The class takes inputs, processes them, and then sends an output. And only the class performing the function cares about how the processing takes place. So our customer orders the coffee, and they give the money, and they expect an output of coffee. The customer doesn't need to know how the coffee is made. They expect the barista understands this process, and they'll provide the proper outcome based upon their order. So if they order a coffee and pay for it, the outcome is that a coffee will be returned to them. In this example, the customer may call a function order coffee, and they expect a return of coffee. And the barista would call their function based upon this, called make coffee, taking the input of whatever that coffee order was, and then they would brew the coffee, pour the coffee, or whatever functionality was required. And the return of that would be the finished coffee. Inheritance says a class can inherit from another class or multiple classes, and the inherited class gains all functions and variables from its parent class. Let's say we have a barista class that knows how to make several different coffee types. And if you know a little bit about coffee, you know that an espresso is the base of many other common coffee orders. So we can use our espresso class as the parent, and then other classes can inherit from that. For instance, latte, cappuccino, macchiato, and any other thing that requires espresso as a base. So in this example, the cappuccino class could inherit from espresso, and the cappuccino class could call make espresso and then use the output of that function to finish the cappuccino. The coffee class has a function called make espresso. And then in the cappuccino class, we can have a function called make coffee that uses make espresso, as well as some other functions. And the return of that would be a cappuccino, which used the espresso in that function. Polymorphism says that each class can override the methods of the parent class based upon inputs. And polymorphism allows a lot of flexibility in your class creation where you don't need to rewrite every function. You can just take what you need from the parent class and rewrite the rest. An example would be something like a chai latte. You don't want to use an espresso in a chai latte, but you may want to steam the milk the same way as a traditional latte. So the chai latte class can override the make espresso function with make chai, and then it can call make steam milk function from the parent. So I hope you enjoyed this trip to my coffee shop, and I hope this was a useful lesson in understanding some of the basics of object-oriented programming. Thanks for watching.